And now it's time for the latest exciting episode of Doz's Television Workshop.
Hello and welcome back to Doz's Television Workshop. This is part 3 of finishing the Bush TV22 that I should have done 9 years ago. First things first, let's get on with that line transformer. Okay, so the website has revealed a photograph. It's a bit dull, but that fits in that way round there. So, in she goes. Well, it's secured underneath by 2 brass bolts, so that's going to be a juggling act. I did have to relieve this bracket slightly with a file, so the bottom of the transformer drops in. I suspect the pillars have moved slightly while it's been kicking around in the workshop for 8 years. So I think the next thing to do is to get the set sort of back on its side, like that, and try and get the nuts on the bottom of our transformer. Okay, so there's a nut, there's another nut, they're 4BA in size, so that fits in like that, and then we can, I don't know whether you can see any of this, to be quite honest. We've got to get a nut up under there on the bottom of the transformer. Right, that's one started. I did run the nuts, by the way, up and down those threads a couple of times off camera, just to make sure there was no sort of lacquer up behind it. I'll tell you what, let's treat ourselves to a washer if we've got the space. Be a little bit careful of adding washers in and things like that, because if you do, you've got some high voltages floating around on there, so we don't want to create a short circuit path or somewhere it can flash over to. Okay, that's going together quite well. Just spin that one up. I think I'm going to put a washer on that other pin as well. Okay, right, now, thankfully 8 years ago, in my ancient book of notes, I wrote down where the wiring went. However, one thing does concern me is we've got 2 yellows. I think that one goes in there because it's up at that side. Can you see any of this? Let's have a zoom in on that camera. So you can see, here is the transformer, there's the 2 bolts, and we've got various bits of wiring, and of course that big inductor that was in the way. So that is, there are 2 red wires here. That one goes back to our capacitor, doesn't it? So I'm going to leave that till last, I think. So we've got a yellow wire that goes also on with that harmonic tuning cap there. So that's okay. We've got a yellow that goes in there. We've got a brown that goes in there. Our anode, which is that red lead floating around from the top of the line output valve PL38. That needs to go through a hole in the chassis. Just wiggle that through. Oh, that's not the hole. That's why I'm making no progress there. That is our anode there. Can you see that coming through? Just about. So that's that wire there. That's going to go to... So we've got red HT, orange. I don't see orange. Ah, there is orange. Orange, yellow, yellow, brown, and the anode is over there. Well, I think I've got to know what I'm doing. I've just got to make it happen now. Right. Yep. Right, so I've just got that yellow and the red to go. And I think for that I need to consult the diagram, service manual, because this is all in a bit of a state of disarray. I'm not even quite sure where it lives. It must bolt on somewhere. But quite where, I'm not sure. That goes to the end of our capacitor. So presumably it goes around this way somehow. Yeah, I think it might be time to have a little look at the service sheet. Okay, we've got our service sheet up. Hopefully this will give us the information we need. So where's our power supply? Must be in the next section down here. Yeah, here we are. So our line output valve is here. Anode is fed through. This is the line output transformer itself. So our inductor should be around here somewhere, surely. Might be listed in the power supply itself. L24 and L25 perhaps. Let's have a look at a chassis drawing if we've got such a thing. There it is, L25. So it's bolted onto the side panel behind. So our line transformer is here somewhere. There you could see that capacitor we restuffed. So it's bolted onto the side there. Sadly it doesn't show its wiring, but there's C31, which I think is the one I've marked as harmonic on my diagram. C31, L25, up here. Where's C31? C31's there. Between D and E. So I've got A, B, C, D and E and F. F is the ground for our EHT winding. Oh no, it isn't. F is the winding for the heaters for the EHT rectifier. So where's the... That's the... No, that's the output of the EHT. That's effectively the earthy end, isn't it, of our EHT overwind. Right, we're going to need to think about this because C31 looks like I might have removed it. L25, C31. L25. Well, we've definitely got a capacitor hanging off one end of the L. L25, we've got C63. I believe that's that one we changed, restuffed. C63, yeah. So C31. C31. Top of the boost rectifier. Goes in on pin D. It's nowhere near L25, is it? Right, let's look at this again. L25, up here, unless it's on the other end. C62. Where is C62? C62, L25. Shout if you see it before I do. C62. This is all frame stage down here. V9, T2, C22, C21. Let me just check that just in case I'm going mad. C31, C62. I think it's going to be down in the power supply by the dropper maybe. Which is over here. C69, R62, L25. What value is it? That might give us a clue. C62. I know it's an electrolytic. That's part of our main can. So I've still got C60 maybe? Now that's going off to our tap, so that will be round by the dropper somewhere. this is a bit of a quandary. C31, C32. Yeah. Right, well, I've consulted the trader sheet, and it would appear our wiring in our line stage is a little different from that that's drawn in the diagram. So I'm going to go with what I wrote down 8 years ago and put it back like that, and just hope I was paying attention all those years ago. So first thing I'm going to do is I'm going to remount the inductor back to the chassis. It appears that we've got 2 witness marks here. You see that? I'll widen the angle out. Let's bring it in a bit then. Oh. So we've got 2 witness marks on the chassis where the inductor sort of bolted up. So yeah, let's try and get that back in place. So there's 2 washers that seem to be about the right size. And we've got an assortment of other bits and pieces, so yeah, let's go with that. Pop some screws in there just to hold it in place, really, and I'll bolt it up from the back. Now the problem with this is this completely obscures both mine and your view of what we're attempting to do here. So this is going to be great for telly. Oh dear. Right. Okay. Where is the capacitor? That is there. That yellow wire, I've got to strip that back. That red wire is ready to go. I'm going to not do that for a moment. I'm going to put the most difficult one on first, get it out of the way, the yellow. So let's just... My word, 23 minutes just to solder on 3 wires. Access is horrible, visibility is horrible, lighting is horrible. Probably made the worst YouTube footage ever. Anyway, I need a cup of tea, and then I'm going to come back and have a bit of a think and work out what we do next. Right, well, I've had a nice cup of tea, and we've got a few jobs left to do. I've got to make an EHT lead up between the anode button and the output from our rectifier. Need to refit the shield around the output stage, and yeah, this lead that feeds the grid of our tube from the RF deck video output is in horrible condition, so I'm just going to replace that. Let's get some fresh solder in there. There we go. That's our new video output lead. That one can go in the bin. Right, what remains still? Right, so the shield is currently drying because it's been a good wash. But the EHT lead goes from the output of the rectifier to our EHT button. And I've looked around in my box of miscellaneous valve type connectors, and I found this thing. Now, the usual sort of top cap of a of a line bottle is smaller than that is by quite a margin. But I found that that fits on there beautifully. So I'm going to use that. It's a nice ceramic thing. And I've also got a piece of EHT lead, which should be long enough. By the time we've gone through the hole in the transformer, that's going to be ideal. Hole in the shield, by the way, not the transformer. This was left over from the Pi 169 shenanigans of yesteryear. So I'm just going to trim a bit of this back. So you can see it's a sort of double insulated cable. And see if we can extract this sort of centre electrode and then solder onto it. I think it's designed for a push fit sort of thing. There we go. But we're not going to be using that. And I want to solder that on the back of there. So yeah, let's just tin the rear of that up. Hopefully it takes solder nicely. Which it does, it's beautiful. Okay, we shall tin our lead. Okay, and I shall just push that through there first, or should I put it back through afterwards? We'll put it back through afterwards. So that can go on there. That's great. It needs to sort of go in that way. So is this cable going to squeeze through the hole is our next problem. Just about. There we are. Come on. There used to be a guy selling these ceramic valve bits on eBay. I think he was called Big Daddy or something. I think he's gone now, which is a bit of a shame, because delivery was good and he was not expensive and the quality was always quite nice. I suspect they're all sort of come out of China these days, but there we are. Right. That's interesting. How is that going to fit back in there? Of course, I'm at a bit of a jaunty angle because of the... There we go. Because of the wiring. Oh, this could be an issue. The connector is sort of held into the ceramic by a sort of tang that doesn't want to go both ways. There we go. So that's made that. That'll just squeeze on our anode button. And originally these were exposed. I think I said about it before, so it's quite easy to get a zap off them. So hopefully that'll be a bit less easy to get a zap off it. Okay, let me go and retrieve the shield and we'll fit that. Okay, my shield's finished drying out. It fits in there like that somehow. So what I'm going to do, I'll drop 2 screws in the hole and do the nuts up from underneath, which is sort of going to involve me putting the thing on its side again, isn't it? Right, put the valves back about the way, valve holder parts, there we go. Right. Ooh. Gently, gently. There we go, so here's the shield. I needn't have done that because these nuts are on the outside except for that bottom one. Okay, let's just... Yeah, I think let's get those 2 in and then put the one that's inside in separately. Okay. And I'm going to need to find a screw to go in that last one because it appears to be missing. Right, now I know I am fresh out of Imperial nuts and bolts, I think. So we might have to commit a sin and put a metric one in. Right, I think that'll do us. Even the simplest jobs on this set have been an absolute nightmare, just because of access and what have you. Anyway, let's get this EHT in place. Right, we're getting somewhere. This piece slots into there, like that. Cool. There it goes. And there's some sort of self-tapping screw to go through there. Might be one of these little things. Right, well, we're making progress. I think it's time to reintroduce the RF deck and get ready to power it up. So that lead lives on there. Okay, and the video connects to this lug here. Our EHT needs to be connected. And then we're ready to power on, I think. So, yeah. Let's make that so. Right. It's time for action. I've got a camera on the screen. I've turned the workbench light off. We're lamp limited, we're isolated, and we're being supplied by a Variac. So now is the big time. Let us put some volts on. Okay, we've got 78 volts. Let's go straight in at 100, shall we? There's 100 volts. And give that a minute or two. I haven't got a signal going into the set because I am likely to need to adjust the ion trap magnet, so which seems to be very stiff all of a sudden. But we'll wait to see what sort of picture we get. We're drawing 130 milliamps, so not a lot. That tube base doesn't look as on as it might be. Yeah, I think that's on enough. Back on. Right. Let's give it a little more oomph. So there's 120 volts. Got a very slight glimmer from the dim bulb tester. There's 140 volts. Just see what the set's getting. You see the set's dropping quite a bit across the bulb. There's only 104 on the set. So I'm going to go up a little. So I've got 125 volts at the set. Got a way to go yet. So I've got 160 volts at the set. And that's all I appear to be able to muster. The bulb is quite bright. Let's just turn that out for a second. Click the bulb out and go again. Oh, I can smell something getting hot. So we've got 170 volts at the set, 220 milliamps flowing. Nothing yet. No heaters. Oh, I can just start to see the rectifier heater. Not the rectifier, that's the sound output. How's our rectifier doing? Yeah, we have glow in the rectifier, so we should start seeing some action. I can hear something coming to life. Oh, I think we've got a bit of action from the sound. Can't hear any action from the line stagers yet. I can see the CRT tube heaters are lit. Can't see any glow from our EHT rectifier yet. Oh, we have crackles from the speaker. I think I can see a glow in the EHT rectifier. I can hear the line stage. The line stage is oscillating. We don't have a picture, but that's okay. Yep, we've got an EHT rectifier heater. Just see it glowing. Right, but we don't have a picture, and that's not really surprising because that's volume, that's therefore brightness. No, okay. I think it might be time to attempt to adjust the ion magnet. We're up at 230 volts now. Right, I'm just going to stop there because this ion trap magnet does appear to have seized back up again. Nothing's easy on this set, is it? So let's just give that a little squib of WD-40 and see if we can get it to slacken off again. It's definitely undone. It's just seized on there. There we go. Okay. So back on with the power. And see if we can get some screen showing. Okay, I can hear the line stage starting. Whoa! Something failed spectacularly. What happened there? We appear to be drawing a minimal amount of current, so something has just let go. Okay, more fault finding. Right, well, it's the following morning. I was tired last night and having that failure, thought, right, no, I'll go and sleep on it. So having slept on it, I got up this morning nice and early and inspected the set. And I can't really see anything wrong. And there's something else that we that experienced when it went fucked yesterday. There was no funny smell. There was a smell of a hot dropper and the valves warming up, but that was it. There was no capacitor venting or anything like that. We just lost the line stage for some reason. So I minded this morning to switch on and see what happens. With that end, I've equipped myself with the EHT meter so I can see if our line stage is going and making some EHT. I expect sort of 7 or 8 kV. Anything around there will give us a picture. So yeah, let's just do it. I'm just going to bring it up by the limiter. So I've got full mains available. So there we go. And I do have quite a bright lamp there, but we did yesterday. So let's just let that bring itself up gently. Oh, let's attach my ground probe to my EHT meter before we make that mistake. Again, we haven't adjusted the ion trap or anything, so that will require adjustment. But let's just see where we get to. Right, I got 161 volts. I'm going full mains. There we go, 230. We're at 237 this morning. I've got heaters in my rectifier. I've got heaters in the line output valve. I've got heaters everywhere. This is good news. Right, I shall arm myself with the EHT meter. Pop that on our output tag there. Have we got that in view anywhere? You can just see it on the edge of the top there. So that first big division there is 10 kilovolts. I expect it to be south of there. Right, I'm getting some sound. That's the line stage I can start to hear. I'm getting no EHT. Oh, there we go. I've got EHT. Okay. Right, I shall now quickly adjust the ion trap magnet, and there we go. There it is. We have a picture. Where is it? It's gone. No, there it is. I need to adjust this for maximum brightness. I'm a bit nervous about doing this. Looks like we've got a lot of line fold over, which is not ideal. I am very nervous about this. But there we go. Right, we have some semblance of picture. So let's just see if we can get rid of that fold over. We've got plenty of width. Oof, frame hole pot is scratchy as hell. But there we go. Right, we've got a picture. Okay, I think the next thing to do is just power down. And let's organise a signal for the set and see if we've actually got anything approaching information from the signal. So a picture. Right, let's do that. Right, just a little update really. I haven't been in the workshop for about 3 weeks because I've not been very well. I've had a little bit of a tidy up though. If you can see behind the sets there, those awful yellow drawers that have been bothering me for years have now gone, and I've put some better component storage in there, and actually it's made the bench seem a lot bigger. It's no bigger really, but yeah. Anyway, where were we? We were going to put a signal into our TV. So I've added a piece of coax just into the connector on the rear here. There's no plug, it's just a sort of saddle and clamp arrangement. That is feeding up into the workshop RF system, which has currently got a 405 line signal coming down it on channel 1. So yeah, we are ready to switch on. Oh, one thing I found in the big tidy up, I actually found a genuine Bush 2-pin mains connector that fits on there, look. So they're expensive, goodness knows where I got it from. But yeah, I shall be using that. Right, okay, it's time to put some power on. There we go, and we are on. Hopefully nothing untoward has happened in the last few weeks, and we still get a picture. That iron trap magnet's loose, so I may have to align that up a bit. Let's just dim the lights. There we go, so you should be able to see the valves glowing in a minute, I should think. Right, have I got anything glowing? Are we drawing any current? We are, okay. Yep, I'm starting to get glow. Yep, the rectifier's glowing. Good, good, good. So let's see where we get to. Always a gentle smell of warm dropper filling the workshop. I can start to hear the line stage, so that's good news. Got a strong line whistle, excellent. Can't hear any sound from the Aurora. Oh, just an alter on the tuning control here. I thought we'd have had a picture by now. Let's give the old ion trap magnet a quick tweak. I've got an EHT rectifier lit, so there we go. Okay, we've got a little bit of frame roll, which I think is this control here. Oh, there we go. And we don't appear to have much in the way of sync. Oh, there we go. Right, this is line hold, so okay. We have a line sync issue. The frame looks awfully egg-shaped. Yeah, you can sort of see the outline of the test card in there, so we're getting somewhere. But yeah, there's precious little line. Appears we definitely have a syncing issue somewhere along the line. Okay. That's interesting. The brightness is affecting the focus, probably because the line stage is running horribly off frequency. It's all affecting one another, and we've got a horrible chunk of line fold over in the middle there. Volume control really crackly. Right, let's switch off, and I think the next thing to do is to consult the service sheet. Right. Okay, I've got our trader sheet here. Let's see what it has to say about line hold. I think it's done around here, if memory serves, around V7. Let's just have a little look at the diagram. Yeah, there we go. So R29 is line hold. C26, C25, C24, they're all going to affect the frequency at which that operates. Now, CC25 is adjustable. So let's just see what is said about C25. Vision interference limiter, that's all on the RF deck. Scroll down. Brightness is controlled by V6. Passed to the grid of the sync separator section of V7, which is the ECL80. That's the valve just on the outside of the line sort of enclosure. Okay. Where the positive going sync pulses produce grid current, which biases the valve to cut off, blah, 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 restoring the DC, blah, 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 blah. Amplified sync pulses appearing at the V7 anode are passed on to the 2-valve multi-vibrator and line time-based oscillator, V7, and the output valve itself, V8. Line hold R9, line linearity by T1, which has a preset variable ion dust core in the anode supply to V8. Right, T1 is line lin. So that may be responsible for our foldover. What concerns me is all this is in the area of the line output transformer, which we've taken out and refitted. Right, where does it mention C25, the adjustable? Preset variable ion dust core. Output from the V8 is transformer couple, blah, blah, blah. Width control L16. That's the one I was sliding on the back. Which is a constant load thing. D and E, damper diode, blah, blah, blah. First anode of the CRT is running a Metrosil. Well, that's all working because we've got a picture. Negative going fed into an integrated and pulse shaping circuit to the anode of a frame blocking oscillator. It doesn't mention C25, here we go. HT current is supplied by blah, blah, blah. General notes. Valve heaters. Where's the bit that refers to this bit? Width line linearity controls are independent. Adjustment should be carried out in the following order. Height, lin, frame hold and focus approximately to the center, line hold control to maximum clockwise, and the line linearity screw head is just flush with the chassis. So that line linearity thing, that was line linearity. It mentioned that up here, didn't it? Width control, line linearity by T1. That's there. Right, where is T1? Let's acquaint ourselves with it. It's going to be on the top chassis. T1. And we can look on the sheet here. Transformers T1, that's in location D2. A, B, C, D2. T1 is there, line lin. Okay. I'm just looking at the back of the set, and when it says it's got to be wound out until it's sort of on the edge of the chassis, I can't see that in there. So, right, okay, well, we can find that in a minute. C25, which is our adjustable capacitor, is there on the tag strip. This is going to be difficult to do with the RF deck in place, isn't it? If not impossible. Okay, where were we? We were down a bit from here. C25 to minimum capacitance, switch on the receiver and adjust for normal operation, adjust the various controls in the order for optimum picture. Line hold, focus, frame hold, leveling the deflector coils, picture shift, width, height, frame, line lin. Right, now adjust C25 for maximum EHT, measuring it with an electrostatic voltmeter, C33 for minimum kink in the line formation on the left-hand side of the picture. Where is C33? C33, B2. Is that even adjustable? B2. B2. C33, that's the one on the scan coils. Okay, that's doable. Adjust C25, adjust C33 for minimum kink. Adjusting C25. Whenever a new PL38 valve is fitted, it's essential that picture is correctly synchronized on a BBC transmission. We don't have one of those. We have the output from the Aurora, which is quite accurate. Set the width ½ an inch inside the mask. Adjust C25 for maximum width and maximum EHT, reducing the width control as required. Point beyond and look for a white vertical bar on the screen. Adjust C25 until it disappears. That is possibly that line foldover we're seeing. If there's any difficulty removing the bar, adjustment of the line linearity control will help to correct it. Right, I think we know what we're doing. Let's get back and take the thing apart. Right, I'm just questioning my train of thought here a little bit, because it does say, you know, if you change something like the line output valve, which is that fella there, that you need to make these adjustments, but we haven't. But the one thing we have done, of course, is we've stripped all that pitch off the line output transformer, because as I've stated, this set has previously worked. So I think what I need to do is just double check my wiring on the bottom of the line transformer, which could be tricky, but we can see most of that, I think, and then go through that adjustment procedure and see if we can bring the set into alignment. So first thing I need to do is I need to just remove the RF deck again and work out how we're going to get at all those bits and pieces. That line linearity transformer, by the way, is that little screw there. You can just see the label still left above it, and it says line form on it. So yeah, that's that control. So yeah, the thing I need to concentrate most on really is getting that line rate correct so we can get sync operating as it should be. I think what I'm going to do is take the RF deck out, put the set back on its side, and then I can get to the relevant adjustments. Because I think we can operate without that being in. And I've just pulled the wire off there. Right, let's make that with a clip just to get things running. Right, so I want a clip lead on there. That'll do that. And one back on there. It's quite possible, of course, we've got some of those resistors in the line hold controllers out of specification. Right, let us put the set on its side. Oh. Okay, that's going to be okay. So the line stage is at the bottom there. Oh, we can see that trim pot quite easily, the trimming capacitor there. So yeah, right, we're going to want power back on. Okay, so I'm just going to check that. That capacitor, the one that hovers between the transformer and that inductor, has come unsoldered. That's quite good news, because that will give us that symptom. We may not have to make any adjustments at all. Now, this is going to be fun, because in my tidy up, I've tidied my notebook. One moment, please. Notebook duly located. So which tag was that on? I folded the corner of the page over. There we go. It's the yellow wire. On the top. So it's that one there. Okay. Right, let's solder that back up and see what happens. Right, let's power up and see if we get any improvement. Right, the power is on. I shall dim the lights. Tube heaters are lit, so we're away. Here we go. No, it's still massively out of sync, so that's made no difference whatsoever. And we've still got that huge amount of fold over. Okay, let's just switch off for a second. Bring up the service sheet again. I shall look at it over here. Set C25 to minimum capacitance. Set the line hold control to maximum clockwise. So that's going to be that way. Set the width to about 1/2 inch inside the mask. C25 for maximum width and maximum EHT. Reducing the width control as required. Okay, so we need to tune that all the way out. I think I might choose an insulated tool for this. Okay, that's approaching minimum. Let me get an insulated driver, because I don't want to be poking around in there when it's running, because I don't know what volts are on that control. Right, okay. And I'm not achieving anything like sync there. I wonder if that form control makes any difference whatsoever. So let's just get on that. Let's just switch off for a second. Don't appear to be making much headway at all here. I think we have a fault somewhere. Maybe a miswiring problem where we... It appears to be increasing the frequency of the oscillator. It is decreasing it, but not enough to where I can get line sync. Oh, well, that's better. It's lower now. Still got this horrible fold over problem. No, I think what we need to do is look at the value of the resistors in the bottom of that control and double check the wiring to this output transformer, because I'm still not convinced I've got it right. Okay, let's put a stop to things there. What I might go and do is see if I've got any photographs from when I took that transformer out originally, and just to sort of double check with those. Right, bear with me. So I actually looked on my Google Photos, and sure enough there's a photograph there, and in fact it's also on the website, and that transformer wiring is correct. The only thing I could have possibly done is rotated the transformer 180 degrees, but we know that's not the case because I've got a picture of the top of the transformer with the orientation of the rectifier. So that's encouraging. And then I got to thinking, well, the sinks come up on this now white clip lead because I've just broken that off. So I wonder if we've got any sinks there. And I was just looking, and sure enough, this capacitor here, I don't know if you can see that. Let's have a little zoom in. That capacitor there, formerly replaced 8 years ago, was hanging in free air. It wasn't connected to anything. Now that is the sinks. So without sinks, I don't think the set's going to work properly. So with that in mind, I've resoldered that. Let's give it some power again and see if this time we manage to lock. Oh, now that looks more promising. And there you have it. Now it's fizzing about like that because the actual RF output isn't that good. There we go. It's producing test card C quite well. Excellent news. That was easier than it was than I thought it was going to be. So fabulous news. Let's clean the pots up and start thinking about the cabinet. Right. It's Future Doz here again, doing the editing, and once again, this episode has gone on too long. So come back next week and we'll put the set back together and sit down and watch a TV programme, I think, maybe have a glass of wine. Until then, thank you very much for watching. Click like, subscribe, do all that rubbish, and I'll see you very soon here on Doz's Television Workshop. Cheers. Hello and welcome back to Doz's Television Workshop. This is part 3 of our Bush TV22. Hello and welcome back to Doz's Television Workshop. This is part 3 of finishing. Hello and welcome back to Doz's Television Workshop. This is part 3 of our Bush TV22 series that I should have finished 9 years ago. Let's get on with it. Don't know where we were up to though. Right, one more time because let's refit the line transformer, isn't it? Yep. That'll do. That is recording. Are we all recording? We are, for the benefit of the cameras. Tascam 356. Okay, I've looked at the service manual, the trader sheet, and the wiring in there differs. Do it again.